Okay, so let's begin creating a new project in Unity. So this time this project is going to look at creating some sort of puzzle game. So the previous project you worked on creating like a platformer. Now we're going to move on to a first person puzzle game. So we're going to have 3 rooms consisting of 3 different puzzles. So the first room is going to be a pressure pad. So you stand on a pressure pad, it would open a door. Second room is going to be a color puzzle. So you activate a block. Once you activate the block, you will then select the color that is on the screen. So then you'll do it 5 times, and once you select the right order of colors, you will then be able to open a door. You then move on to the third room, which is picking an object up and placing that object on a pressure pad, which then opens the door and then completes the game. So let's just quickly see that in action. So you'd also create a main menu. This is a very simple menu. It's just got one button, which is the start button. That button will take you into the main game. So we hit start. So there's room 1 completed. Now we go into room 2. And then from here, we start the level. So hit part. So now they're completed. We're into the final room. These are going to be 3 statues. What you'll be doing in your game is you're going to replace these with your own models. But we're just blocked out for my game for now. So I'm going to pick this one up. I'm just going to drop it on. This works. No, it's the wrong puzzle. With the wrong statue. So let's try this one. Oh, trapdoor there. And this one's correct. So there's a bit of a glitch here. That's something I can refix. So then we're back, and then that's basically the game completed. There's a little glitch with the statue puzzle, but that's something that's easy to fix, which I will have fixed before we get onto that lesson. But for now, let's walk you through everything you need to do. So let's stop the game. For you guys, you start creating a new game. So we'll just call this Sci-Fi Project. Now you'll call it whatever you want to call it. I'm going to call it Sci-Fi Project. Okay, so now we're in the game. So let's just firstly rename the scene. So press F2 to rename, and we'll call this level 1. I always like to name the first scene level 1 because it should always be your first level, and then we always create the main menu separately. I want to make the game first, then the main menu last. So with that, what we'll first do is create our player. So previously you imported a player controller. We're actually going to create our own this time. And to do this, it's very simple. It's just a case of right-clicking, 3D object, and it is going to be a capsule. So press F to zoom in on this capsule. Let me just dock my game elsewhere for now. So this is our capsule. Just a simple 3D capsule. Let's rename this to player. And then in the tag, name it player. Okay. So, next step is to right click and create 3D object and just create a cube. I'm going to explain why I'm creating this cube in a minute. I'm going to call this cube eyes, and I'm going to make it a child of the player. Just let's reset all the positions. So X, Y, and Z to 0. Press R to resize this. Just drop it down and in. Bring it down slightly. Yeah. Basically, this is just mapping out where I would expect the player's eyes to be, because we're mocking some eyes here, and I would expect the eyes to be about here, just there. This kind of mimics our player's eyes very nicely. The next step is to grab the camera and just dot the camera basically in front of the eyes. So grab the camera, just here, just turn it around, 180. Where the eye should be, set that to 0, 0, just to reset it for a second. And then if you look at the main camera here, just make sure you position the camera just so this block here isn't in view. Because you don't want any of that in view, so you want it to get rid of it there, about there. Maybe a little bit of front. And then that's basically what the camera is now going to be in front of the eyes. So it just keeps the camera stuck to the eyes. And just rename this to camera. And it's already tagged as main camera for you, which is great. Control S to save. Okay, so previously we've been giving you the scripts, and we're still going to give you the scripts, but we kind of want you in the lessons to do a little bit of the coding yourself. Now, for the video tutorials, I'm going to walk you through all the code. In the classroom, you will have half the code, but depending on how far we are into the project and how advanced you are getting with the coding, we are going to make you do certain steps. So for example, for this step in the classroom, you would be writing the variables out yourself. So you'll be declaring all the variables. Now obviously this is post lesson. So because this is post lesson, I'm just going to run through all the script as it should be. Okay, so let's make some folders first. So the first folder we're going to make is scripts, obviously. And then right click again and create another folder, call this prefabs. And then make another folder. Let's call this SFX, which is for sound effects. And another one for music, which is obviously music. Another one which will be materials, and another one which will be textures. Okay, so in our scripts folder, let's start creating our player controller script. So right click, create, C# player controller. Let it compile, double click to open. Drag this over here. That should get rid of the start and update for now. Okay, so some of the things we need to do. Firstly, we need to make the variables. And for a play controller, you should have a walk speed. This one we're going to allow to run, so we want a sprint speed. We're going to allow it to jump, so we need the jump height, and then to mimic how fast our character falls back to the ground, we're going to need some sort of gravity. So that's what the settings we're going to do for now. So when I create scripts that require multiple variables to have references to them. So for example, you drop your camera onto it, or you need to change like the walk speed, the sprint speed. I always use what we call headed. So in order to do that, you do open square bracket. Obviously, Visual Studio has closed it for us, which is great. But we type in header, Header, open brackets, and we just type in for this one movement settings. And this now, when we hit save, so I hit save, It's not going to compile at the minute because it needs something. So let's put one variable for now then. So serialized field, private, float, and we'll call this walk speed. For now, we're just equal to 5. So let's go back to Unity. On our player, we just drag this on, and then walk speed. But you notice it's actually got now a header above that for movement settings. So all the movement settings are going to be nice and neatly ordered underneath this header. I can then have another header which is for a different set of settings. So for example, mouse settings or camera settings or anything like that. So it just keeps it nicely organized. Okay, back to the script. We also need to declare a sprint speed, a jump height, and a gravity. So serialized field, private, float, sprint speed, and this should always be double really your walk speed, so we'll give it 10. Serialized field, private, flow, jump height. So this is how high, this is how much kind of force we're adding to the height. 2. Serialized field, and this is our gravity. Let's set this to something like minus 9.81. Okay, so what are these doing? This is how fast the player will walk. Right. Okay, so again, if I do another header, and this time called up mouse settings, let's make another private variable. So in fact, let's not do a header, we won't need one. So I just hit Control S and save, and we come back to, in fact, yeah, let's just do another header just so you can see this in action. What I'm about to make actually doesn't need it to be serialized, but we'll just do it for this example. So serialized field, private, float. In fact, yeah, no, we'll make it so it's editable in Inspector. So private float, mouse sensitivity. If we go back to Unity and, oh, wrong one, and compile it, you'll see now we've got a header and all the settings that are related to the movement speed, and then we've got another one just for mouse, which works fine. Okay, so let's go back to our script. Let's start declaring some more variables now. So these are all on our private variables. So private, a vector free, velocity. So this is how much velocity we're going to apply to the player on a vector free. Remember, a vector free takes 3 parameters: a transform, a scale, and rotation. It's a vector free. So let's just call it velocity, and then we need another private float. And origin speed. 2 seconds. Let me pause this. So make the private flow origin speed. So this is the origin speed of the character. Let's call that original speed. Let's make a boolean actually. Just basically a check to see if the player is grounded. So once the player jumps, it's grounded becomes false. Now, if grounded is false, then basically we can't jump again. So it avoids the double jump. Private transform. So a transform, and it's play camera. Reference to the main camera. So basically, this is the rotation on the x-axis. We set that to 0. Reference to a game manager. We haven't made that yet, so let's put this. So that will come up in later on in another script, which we'll put there now for reference. Okay, so we need to first make a start function, and in the start function, what we're going to do is get our references to all our different variables. So private start first the controller. So controller is equal to. Oh, sorry, we haven't put that reference in. So what this is a reference to our character controller. So controller is equal to get component character controller. So basically, we're going to get a reference to the character controller from the player's game object and store it in controller. The original speed or the original speed will be equal to walk speed. Then what we're going to do is find the camera and attach the camera to the player. So sudo we just find camera and attach to the player, and it's play camera equals camera dot main dot transform. And then if player camera is equal to null, this is a null check. What a null check does is basically checks to make sure that the object isn't empty, and if it is empty, throw up an error. If it's not empty, then do something. So to do that, we just do debug dot log error and no main camera found. Ensure camera is tagged as main camera. So then we lock the cursor, so basically you can't see the cursor on the screen. So basically the cursor, which is obviously this, gets locked and then isn't visible on screen because you don't want to see it in the first person. You don't want to see it in the game at all. So we just lock and hide it. So what this does again, it's going to get the main camera and store it in the play camera variable. If the play camera is null, so what a null check is, a null check basically checks to make sure that the variable holds something, and if it doesn't hold something, you can throw up an error, so a debug.error, and then this will tell you what the error is, and then you hit return and it just returns it again. You just want to make sure that that object holds something, and if it doesn't, throw up an error. Then private void update, so the update function, and then we're gonna handle the player movement, and we're gonna hold these into their own methods. So move player, and then we're also gonna have a look around. So look around, or camera movement. So look around. So make these methods, functions, deployed, move player, check if the player is on the ground. So I'm just going to write the code out and explain what's going on here. So what we're doing is we're going to check if the player is on the ground. So is grounded, so is that if that boolean is yes or no, it's going to be yes or no based upon whether on the character controller, the character controller will detect whether the player is on the ground. And if grounded and the velocity.y is less than 0, then what we do is set the velocity.y to -2f. Okay, and then we're going to handle the movement input. So movement input flow move x is equal to input dot get axis, and flow move y equals input dot get axis. So again, what's happening here is we're making two variables, a move x and a move y, and that value is being fed from the input dot get axis horizontal. So we hover over. What this does is the get axis returns the value of the virtual axis identified by the axis named. In this case, it's horizontal. In this case, it's vertical. So if you are moving horizontal, so left to right, which is the A and D key, that's what this is going to be on the X. If you're moving up and down, Y axis, and then you call vertical, so it's either up and down on your analog stick or W and S on your keyboard. And then it stores that in the move Y. So let's do sprinting. So flow speed equals input dot get axis, we'll get key down, sorry. So what's happening here is we have a float of speed, and if the left shift is pressed, then sprint speed becomes the float of speed, sorry, becomes the value of sprint speed. Otherwise, if the left key is not pressed, then it's basically going to be walk speed. So it's basically, this is a shorter way of writing an if else statement. So if you want to shorten down your if else statement, you can write it out like this. So you have the variable that you want to fill, and then you have two conditions. So either left shift is pressed or it's not. And if it's pressed, sprint speed. If it's not, walk speed. It's the exact same way of writing out like this. So you can write if input dot get key that. speed here. So basically, this is the same as this, but this is a much faster, shorter way of writing it out. So we stick to that first way we're doing it. Okay, so make a vector 3, move. That's transform dot right times move x plus transform dot forward times move z. Now we don't have a move z just yet because I've made a move y by accident. It's actually move z. So remember, this is moving left to right, this is moving front to backwards, so it needs to be Z because obviously the y-axis is up and down. In 3D, you'd be moving in Z spaces on the Z axis, so that should be changed to Z. So what's happening here is we're making a vector 3, and in that vector 3, it's transform.right times the move X plus transform.forward.move Y, times move Z, sorry. So what's going to happen is either going to move left or right based on the axis. So remember, the axis can either move. In fact, what we'll do is, just so you can see this in action, we can do a debug. So debug.log. Let's do it as an update. I'm gonna write this out just so you can see it in the log. Let's just comment this out so there's no errors. So we go to the console. Oh, we can no character controller. So that's a good time to actually add the character controller. So add component character controller. And then let's go back, clear. In our debug log, let's just make it visible. So close out, make sure I'm still recording. Yep. So obviously my current horizontal axis is 0, but you notice if I'm now pressing the A key, so I'm going minus. If I press the D key, I go in the positive direction. And it goes from 0 to 1. Okay? So, sorry, it's 1 to minus 1. So, all the way to using the A will go minus 1. And to using the D key, it will go to 1. And that's getting the axis there. Okay, so that's what's happening there. Then basically what we're doing is, if I get rid of this, pop this here, on here, move X is either going to be -1 or 1. And then obviously when nothing's moving, it's 0. It zeroes itself out. So move is transform.right times the value of the move X, so either -1 or 1 or 0. And then transform.forward times mu z is either going to be negative or positive 1 or 0 if nothing's happening. You're not moving at all. So move the player. So now this is actually moving the player. So to move the player, we just do controller.move because we're inheriting the character controller, which is this here. So this has its own set of methods we can call. And one what we're calling is move, and then we're going to give it value. So the value is the move value times speed times time dot delta time. Remember, time dot delta time is called every frame. So it's our speed that's getting timed every frame. So we're taking this move in whatever direction we need to move in. We're timing that by whatever the value of speed is. So either it's the walk speed or the sprint speed, and then we're timing that every single frame. And that's what allows our player to move. Now let's make the jumping mechanic. So jumping, if input dot get key, sorry, get button down, not key, and it's key code dot, oh sorry, it's actually not key code, it's jump. So basically, if we press the jump button and we are grounded, we can add some velocity. We can set the velocity .y to the jump height times -2 times gravity. So what the jump button is, if you go to your project settings and the input manager and then axes and come to jump, the positive button is space. If you're using a controller, you come to jump again, and then it's joystick button 3, which tends to be triangle. So when you press triangle or Y, you'll jump. If you press space, you'll jump. So what the input manager does is it allows you to create an input and map it to a particular button. So in this space, triangle, Y, or space. So come back. And then we're just going to apply some gravity here. So now remember, all this code is already going to be written for you. I just want to break it down. And the easiest way to break this down is actually run through the code bit by bit with you. But what you'll be doing in the lesson is you would have already made these yourselves. Okay, so next step is creating the look around function. So private void look around. So float. So what's happening here is we're creating two variables which are floats, x and y, and we're gonna either get the x-axis from our mouse or the y-axis from the mouse. Then we're going to times that by the sensitivity of our sensitivity settings, and then it runs every frame. So basically, it just maps how fast our left and right and up and down will be. So we can rotate the player horizontally, and we do that by saying so we're going to transform off the player, and we're going to get the rotate, and it's vector 3 dot up times mouse x. So basically, how fast will it be to look up? This is a vertical rotation. Sorry, it's not up, it's left and right. Vertical rotation with clamp. And that is x rotation minus equals mouse y x rotation f. So what a clamp is, so let's look over this. Math f is basically a collection of common math functions, so it's just a math function. And what a clamp is, clamps the given value with the given minimum flow and the maximum flow values, so returns the given value if it is within the minimum and maximum range. So what we're doing here is we're saying we can't go anywhere less than minus 90 and more than 90. So it's basically 90 degrees. So you can look up and you can look down, but you can't flip the player. Because if I didn't have this clamp in, what would happen is you'll be able to look right around. You do a full 360. So if I just show you quickly how this looks, go back to Unity. Let's just put like a block under here. So 3D object cube. Scale this cube up. Oh, 2 seconds. We haven't. We haven't actually added the rotations to the camera yet, so 2 seconds. If we comment that out. So what this is doing is a quaternion are used to represent rotations. A Euler is returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y-axis, and it's applied in that order. So we're just rotating on the x rotation, nothing on the y, nothing on the z. But you see how we can now do this 360? We can rotate all the way around. Don't want that. So to fix that, we use this clamp, and the clamp stops it from rotating all the way around. So I add this back in. We're now clamped to 90, and we're clamped to 90. If we come to the camera, you'll see it to 90 degrees now, all the way up, minus 90 degrees. 90, minus 90. But we can spin all the way around because we're not clamping that. So we've already set up the play controller now, so I've already attached it and you can see it in action. Let me just make this block a little bit bigger so I can walk around in it. As you can see, I can now walk. And then if I hold shift, I can sprint. And if I press space, I can jump. So that's all working. I can jump, I can walk, I can sprint. That's how play character can now set up. So let's go to that. What the next step, which will come in the next class, is you guys will go off and you will create your rooms. Now, you will go and create all your rooms one by one. Your first room is going to be a simple corridor with a pressure pad pedal, and then you'll lead into another bigger room, which is just a pedal full of color blocks, and then you'll move into a final room, which is your statue room. And that's what you'll be doing in the next lesson. I won't make a video on that. The videos that I will be doing for you guys is more on the technical side of the coding and adding all that in. To do the blocking out, you guys should already know by now how to block out. You've already blocked out the previous levels for the last project. Then myself and Rob will walk through it in the classroom, but there's no need for a video on that particular component. So thank you for watching. Hopefully this gives you a bit of understanding on how to set up and code a play controller. Thank you.